Hey folks, welcome back. This is going to be the fourth lecture on arrays. And today we're going to talk about sorting an array. And we're going to look at one of the algorithms for sorting an array, which is called bubble sort. So let's talk about why you might need to sort an array in the first place. It's a common thing where you get a set of data and you need to organize the data and present it back to the user. And so an example of this might be I have a bunch of student names, and I would put each name in an array cell, so it will be an array of strings, but I might want to be able to print out the list of names in alphabetical order. And so I might want to sort the array and then print the array. Another example might be if I had all the grades from a test in an array, I might want to be able to sort the array and pull out the top 5 or the bottom 5 or the bottom 10 or some other combination of grades out of the array. So once it's sorted, I have options on how I can pull stuff out of there. There are many different ways in order to sort an array. There are some things that are built into the language. There are other ways that you can write the algorithm yourself. In computer science classes and software engineering classes, we tend to explain how the sort works rather than just using the built-in sort. And it's because we want you to think through how it would go about doing the sort. And so that's why we're going to show you one of the ways to do it in this class called bubble sort. Now, the reality is bubble sort is not a very efficient algorithm. It's probably the first way that you would think to sort a bunch of stuff, but it's not the most efficient way to do it, and it's not something that you'd actually really use in the real world most of the time. But it is still a useful algorithm to understand because you will sometimes need to do something similar to a bubble sort. So having an understanding of how it works is a positive thing. But later on, you're going to learn that there are many other different sorts. If you go on to take some of our later classes, you'll eventually see selection sorts, insertion sort, merge sort, and quick sort, which are all different versions of, or different ways to go about sorting algorithms. We're not going to cover any of those in this class, but we do want you to be aware that they exist. So there you go. All right, so next up, we are going to talk about how you can use the built-in sorts. And truthfully, if you were going to sort something in an array, this is probably what you would do today. You would start off by importing Java Util arrays, which is not something you've ever imported before. So you've imported Java Util scanner, and that's pretty much the only thing you've ever had to import. Well, there are many, many other libraries. The library is just a bunch of extra code that somebody else wrote that you can use inside of your program. Java Util Scanner is one that you've used a lot because it's how you read and write, or how you read information in from the user. Java Util Arrays allows you to do all kinds of cool things with arrays, and we're going to look at one thing that's in there, which is the sort method. The default is that the sort method will sort you from lowest to highest, meaning that the lowest value will be in cell 0 of the array, and the highest value will be in cell array.length -1. There are other possible options you can pass to the array sort method to tell it that you want it sorted in other ways. You can tell it you want it sorted the opposite way. You can tell it you only want to sort a part of the array. And this will work on characters, numbers, strings. So here's an example of using arrays sort. So what you can see is happening here is I started off with an array and I put some random numbers in there. So this is an array of integers. It has 52, 25, 32, 9, 42, and 2. And you can tell that those are certainly not sorted. So then I call arrays.sort and I pass it my array. So let me be clear about the parts of this. My array is the name of my variable. That matches what I defined right there when I created the array. Arrays.sort is a method that is built in arrays that allows me to sort an array. So you say arrays.sort my array, and then at that point you now have a sorted array. So it just does the work for you magically. And then after that, I'm just using a for loop to print out the array. And as you can see, the output, I now get the values back in sorted order, even though they were not in there sorted before. So effectively, the question is, how did it sort this? So eventually this 2 had to move all the way to the beginning, and then the 9 had to move up next to it. And then it seems like the 25 would have had to move over there, the 32 would have had to move to there, and the 52 would have had to move all the way to the end. So there was a bunch of stuff that had to be shuffled around in order to make this happen. And the sort method just does that for you, and you can just call it, and poof, you have a sorted array. But if you actually wanted to understand how you could do it yourself, that's when we would look at some of the different algorithms. So before we move on, let's talk about the other options you can pass into the sort method. And so you can say arrays.sort my array, and then you can pass it something called collections.reverse order. If you're going to do collections.reverse order, you have to import Java Util collections in addition to Java Util arrays. You can also just sort a part of the array. And so, for example, you can say, I wish to sort just cells 1 through cell 5, and this will only sort the values that are in 1 through 5 and leave everything else where it is. And sometimes that's useful if you just have a part of the array that you need sorted. So there are options that you can pass in there. But let's now talk about how you could do it manually. So again, would you ever actually do this? No, you really wouldn't. You'd probably just use the built-in methods. But I still need you to understand how this works, and it is a common question that you get asked in interviews to explain how you could sort an array. And a bubble sort is probably the most universal sort that everybody understands because it's probably the simplest of the methods to do. So the way that a bubble sort works is it effectively bubbles one number into the correct place, and then it bubbles the next number into the correct place, and then the next number. And when we say bubble, what we mean is it's kind of like moving it around until it gets to where it needs to be. So effectively, the way that it works is you compare the content of cells 0 and 1, and you check to see if they are in the correct order, meaning that the lowest one is on the left in 0, and the higher one is in the right on 1. If they are correct, you just move on to the next two cells. But if they're not correct, then you're going to swap the two of them. And then you move on to the next two cells, which is cell 1 and cell 2. You checked if they're in the right order. If they're not, you switch them, and you move on to 2 and 3, and switch them, and switch them, and switch them. At the end of that process, you'll have moved one number into the correct cell at the very end of the array. And then you have to repeat that however many times there are cells in the array. So if you have an array that has 10 cells, you're actually going to do 10 comparisons and possible swaps for the first pass, and then a second pass, which is going to do 10 more, and then a third pass, and a fourth, and a fifth, and a sixth, and a seventh, and eighth, and ninth, and eventually a 10th. So for a 10-cell array, you're actually going to do 10 times 10 comparisons. So it actually takes 100 operations in order to sort the array. So not very efficient. For a 10-cell array, 100. For a 1,000-cell array, 1,000,000. For a 1,000,000-cell array, well, let's just call it a lot. So the next thing that you need to understand how it works is if you have to switch two cells in an array, how do you go about doing that? It seems like there would just be a way to do it, but you actually have to do 3 steps. And so we're going to start off with the example that you have 2 variables, and these are not arrays, these are just variables. I have a variable x and a variable y. X currently has 7, and y currently is set to 8. And what I want to do is I want to reverse them, such that x is now 8 and y is now 7. So the weird thing is, in order to be able to do that, you're always going to need a temporary variable, a third variable, in order to hold some of the information temporarily. So the actual algorithm is, you're going to take one of the values, and it doesn't really matter which one, and you're going to put it into temp. So to be clear, you have x, which is 7, you have y, which is 8, and you have temp. All right, and again, the goal is to reverse these two, so that at the end of this process, they are reversed. So we're taking whatever is in x, and we're going to put it into temp. So temp is now equal to 7. And you're going to see why that's necessary, because if I didn't do this, I would lose the 7. So the next step is I'm going to take whatever's in y and put it into x. So I'm going to take away whatever's in x, and I'm just going to put whatever was in y in it. And you can see x and y are now equal to 8 at this point, and that's where I would have lost the 7 had I not put it into temp. And then the final step is I'm going to take whatever's in temp and put that into y. So take out whatever's in y and put whatever's in temp in there, and you can see x is now 8, y is now 7, which means I have successfully reversed the two values. So this is a very important algorithm. Anytime you need to reverse or switch two things, whether they're array cells or whether they're variables, you're always going to need a temporary variable to hold one of the values for a moment while you do the switching. So always remember you need a temp in order to switch two values. All right, so now with that said, let's take a look at a bubble sort. And what I'm going to do is I'm going to go ahead and code this first. So I'm going to make a new replit, and I'm going to put the array in there, and then I'll come back to you. Okay, so here we are in the replit, and you can see that I have defined the array. It has some values in it that are not currently sorted. So what we're going to need to do is we're going to need 2 loops. One loop is going to do one pass of the array and do the switching as necessary. The other loop is going to do that process however many times we have cells in the array. So these are going to end up being nested loops. So we're going to have for int I equals 0, I less than myArray.length, I plus plus. And then inside of there, we're going to have the inner loop that's going to do the actual single pass through the array. So the way that that's going to work is for int j equals 0, j less than myArray.length, j plus plus. All right, now inside of here, this outer loop, ignore it for just a moment. We'll come back to that in a bit. It has to be there, but just pretend like it's not for a moment. So this inner loop starts off with j equal to 0, which is going to be that first cell of the array, right? That's going to be my array at position 0. So what I need to do is I need to compare that cell with the neighboring cell, and I need to see if they are correct. So the way I'm going to write that is I'm going to say if my array at position j is greater than my array at position j plus 1. Okay, now j is here, j plus 1 is there, right? So if this one is bigger than this one, which it is, then I'm going to need to switch them. So the way that I'm going to do that is I'm going to have an int temp is equal to my array at position j. Then my array at position j is going to get equal my array at position j plus 1. And then finally, my array at position j plus 1 is going to equal temp. So that's the switching part that we looked at before. Okay, so those three lines just reverse the two values. So at the end of this statement, when I have looked at cell 0, it's going to compare 0 and 1, and if they're out of order, it's going to switch them. Now, with this piece of code, we have a problem. J is set to go from 0 to myArray.length. Well, myArray.length here is going to be 6. There are 6 cells in here. So it's going to go from j equals 0 to j equals 5, because 5 is less than 6, but 6 is not. So it's going to do 0, 1, 2, 3, 4, 5. Okay, but look at the if statement. It says if the array at position 5 is greater than the array at position 6. And I can't look at the array at position 6 because there is no array at position 6. There's only cells 0 through 5. So because of this plus 1 in here, I need the loop to stop 1 earlier. And let me just explain it visually. This is the first comparison that it's doing, cell 0 and cell 1. These will be the second comparison. J at this point is 1. These will be the next comparison. J at this point is 2. These will be the next comparison. J is 3. And these will be the next comparison. J is 4. Once I get to J is 4, I need to stop, because if I try to do J is 5, it's reading past the end of the array, and that's not going to work. So I actually need this inner loop to go to myArray.length minus 1. So it's because I have a plus 1 inside of here, I'm already seeing that last cell. I don't need to do it twice, because then I will go past the end of the array. So just an important detail there. All right, so this inner loop is going to go through the array one time, and at the end of that process, it will have moved 52 to the last cell, because 52 was greater than 25, it switched them. 52 was greater than 32, it'll switch them. It was greater than 9, it will switch them. It was greater than 42, it will switch them. And it was greater than 2, so it will switch them. So at the end of that entire loop, when that loop has run all the way, 52 will be at the end. But the array is still not sorted. I need to do the whole thing again to move the next highest number to the correct place, which is the 42, which ironically is in the right place, but the algorithm doesn't know that. So it's again going to do all the swaps and then do the third highest, and then do the fourth highest, and then the fifth highest, and finally the last one. All right, so that's what the outer loop does. The outer loop is what's doing each of the passes. So in each pass, we're doing all the switches to move it to the appropriate place, all the switching. But the outer loop is what's causing us to do that over and over and over again, and the specific number of times it's going to make me do it is 6, because there are 6 cells in the array. So the first time that we do the inner loop, we're going to move 52 to the end. The second time we do the inner loop, we're going to move 42 to the end. The third time, we're going to move 32 to the end. The next one, we're going to move 25 to the end, and then finally we're going to move 2, and then we're going to move, 9, and then 2. So we're going to do 6 passes. Each pass is going to move one number into the correct position, and that's done through the inner loop. Okay, so that's the array and the algorithm for a bubble sort. The last thing I'm going to do here is I'm just going to print out, I'll use a for each loop since we now know how to do that. So for int x in my array, and then I'm just going to print it. System.out.println, x, because that's what I called it. So what I should get here is 2, 9, 25, 32, 42, 52 in that particular order because I have sorted them. And there it is. So you can see that did the same thing as the arrays.sort that we looked at first. Next up, what we're going to do is we're going to see how that traces. So we're going to do our usual tracing, doing everything one step at a time just so we can see what's going on here. All right. So this is the same algorithm that I just wrote. You have the outer loop, you have the inner loop, and you have the if statement that switches any two things that are out of order. I started off with the array already shown up here in the variables. The array is called myArray. And I also started off with I is 0 because of that initialization and j is 0 because of that initialization. All right, so this is our initial starting point. And let's step our way through here and see what is going on with this. So the first thing that we're going to do is we're going to look at I equals 0, j is 0. So the outer loop, we are currently at 0. And we're going to remain at 0 here for quite a while. All right, so we're really only looking at this inner loop for now. So in the inner loop, j is 0. And what we're asked to check is if the array at position j, which is cell 0, is greater than the array at j plus 1, which is cell 1. So is 52 greater than 25? Well, yes, 52 is greater than 25. So now we're going to do a switch. And so we're going to make a temp variable. We're going to set it equal to 52, which is the one in cell 0. We're going to move what's in cell 1 into cell 0. So now there's a 25 in both of them. And then we're going to move what's in temp into cell 1. So that successfully reversed the 25 and the 52. All right, so that all happened because of the if statement. All right, we've reached the end of the inner loop. So we go back up to the top of the inner loop. And at this point, j is now equal to 1. So now the if statement reads, if my array at position 1 is greater than my array at position 2. So it's checking the 52 and the 32. Well, 52 and 32 are out of order. 52 is greater than 32. So we're going to do the if statement again. Temp is equal to the 52. 32 gets copied over, and then temp gets put into the other cell. Okay, so that's successfully moved 52 in there. We've reached the bottom of the for loop. We go back up to the top, and j is now equal to 2. So the if statement says if my array at position 2 is greater than my array at position 3, which it is, 52 is greater, again, make a temp variable, copy over the 9, put the 52 back in there. All right, so now we hit the bottom of the for loop, and we move j up to 3. Again, we compare if my array at position 3 is greater than my array at position 4. It is. So the temp is equal to one of them. We move the 42 over, and then we put the 52 back into position 4. We've reached the bottom of the loop. Go back up to the top. J is now equal to 4. All right, so this is the last time we're going to do this pass. So it's checking if my array at position 4 is greater than my array at position 5, which it is. So we make the temp, we move the 2 over, we copy the 52 back, and at this point, the inner loop has completed. When we go back up to the top of the inner loop, j becomes equal to 5. 5 is not less than my array length, which is 6 minus 1. 5 is not less than 5. So the inner loop has completed, and the inner loop is done. And at this point, we reach the bottom of the outer loop. All right, so at the end of the first pass, what we have done is we have moved one value into the correct position. That is the highest value in the array. We're now going to repeat that in order to move the second highest value to the end. Note, as the algorithm is written, it will do a little bit of unnecessary work at the end. We'll look at an optimization when we get to the end, but just going to go with the algorithm as it is. Okay, so the outer loop has changed I equal to 1. Okay, so I is now 1 because this outer loop has done a I++. When we come back in, we're starting off the inner loop again from scratch. So it begins with j equals 0. And it's again going to go all the way up to the array length minus 1. So now we do the exact same code again. It checks if my array at position 0, which is 25, is greater than my array at position 1, which is 32. Well, 25 is not greater than 32, so there's actually nothing to do there. So we're going to move on. J gets incremented. J is now equal to 1. And that means we're now going to check in the if statement whether 32 is greater than 9. Well, 32 is greater than 9, so the if statement is going to have to fire. All right, so the if statement is going to do these 3 lines. It's going to create the temp variable, which is going to get 32. It's going to copy the 9 over, and then it's going to copy the 32 back, which gives us 9 and 32. They're now sorted. All right, so that's the end of the inner loop. J now becomes 2. We're going to check whether the array at position 2 is greater than the array at position 3. Is 32 greater than 42? No, it's not, so we don't have to do anything. So J is going to increment to 3, and now we're going to check if 3 and 4 are in the right order. Well, they're not. It turns out that 3 is greater than 4, so we're going to need to swap them. We put the 42 into temp, we move the 2 over, and we put the 42 back in the other cell. And at this point, it would actually go on and check the last cell, but we already know that that last cell is sorted because it's physically impossible that the 42 could be greater than the 52. We already moved the 52 over there. So the second pass is now done. The inner loop is done. So we're going to start the whole process over again, doing the third pass. So now I is equal to 2 because this is our third pass, 0, 1, 2. And we again reset J equal to 0, and we again do the exact same thing. Is 25 and 9 in the correct order? They're not, so we swap them. Move the 9 over, move the 25 back up using the temp. Move on to J equal to 1. The 25 and 32, they're already in the correct order, nothing to be done there. Move on to J equal to 2. The 32 and the 2 are out of order, so we swap them. And then again, we would move on to the last 2 cells, but they're already sorted. So the array will actually go on and check J equal to 3 and J equal to 4, but right now we don't need to do anything there because they're always going to be sorted. So that's the end of our third pass. We start the fourth pass. J is now equal to 3, 0, 1, 2, 3. That's our fourth pass. We start J back at 0 again, and we say, is 9 and 25 in the right order? They are. We move J up to 1. Is 25 and 2 in the right order? They're not, so we switch them. And then we would continue on to 3, 4, and 5, and it turns out they're already sorted. And that's the end of our fourth pass. Okay, so now we do our final pass, which is the fifth pass. And in this case, we have 9 and 2. They're out of order, so we switch them. And then we would continue on and recheck all the remaining ones, and they're all going to be correct. And as you can see, the array is now completely sorted. We have successfully moved everything to where it's supposed to be. So the thing I want you to get out of this is, given an array of size n, where n in this case was 6, we're going to make n comparisons to move the highest value to the end, and then n comparisons to move the next highest value to the end, and then n comparisons to move the next highest value to the end, all the way down. And since this is a nested loop, you're going to do n work n times. So you might say that we're going to do n squared work, because the outer loop is going to do n times, and the inner loop is going to do n times, but you're going to do the inner loop as many times as the outer loop makes you do it. So there is an optimization you can make to this, which was not in the original code, and I just added it here and I highlighted it in yellow. In the inner loop, we actually had said j less than myArray.length minus 1, and that's because we only need to go up to, in this case, cell number 4 and compare it to cell number 5. But in reality, each time through the inner loop, we don't actually need to look at the last cell in the array at all. So the first time we do the inner loop, we need to look at all the cells. But the second time through the inner loop, we can do 1 less cell. And the third time we can do 2 less cells. And the fourth time we can do 3 less cells. And the way we can accomplish that is by subtracting the I out of that test as well. So by the time we get to the fourth pass, meaning that I is equal to 4, this is going to calculate the length of the array is 6, minus 1 is 5, minus 4 is 1, and so it's actually only going to do 1 cell, and that's the optimization. This is actually the algorithm that we traced. I didn't show you the extra work where it went off to the end, just to cut down on the number of slides. So this is a correct bubble sort. It is, again, not the most efficient way that you can do a sorting of an array. As a matter of fact, it's probably one of the least efficient ways that you can do it, but it will always work. And it is a useful thing to be aware of because you will sometimes not be able to use the built-in sort method, which you will see later. There are times that the built-in sort method is not going to be capable of doing it. And so in those cases, a bubble sort may be your best choice. It's not a great choice, but it may be your best choice. So that's the end of the arrays module. I just wanted to give a last couple of thoughts in here, which are arrays are incredibly useful. You're going to use them all the time. This is definitely one of those things that when we started all of this at the very beginning of the semester, we were talking about variables and we were talking about using primitive data types and strings. Arrays really are right up there with primitive data types and strings. They're used all the time because it's very commonly the case that you need to pass a bunch of data somewhere to somebody else for them to work on, and an array is a single way that you can do that. So arrays are definitely very useful. If the bubble sort stuff didn't really make a whole lot of sense to you, that's okay. It's not the end of the world. We're not going to ask you to code that on a test or anything like that. But you should be aware that it exists, and you should have a basic understanding of how it works from the standpoint of doing the bubbling and moving things along the array. So that completes the array section, and that is the end of the material for this class. So I hope that you enjoyed all of that and you got a lot out of it. Remember, you can always go back and rewatch the videos. You can also look at any of the replets that are in here, and you should be able to pull them up by simply pausing the video and typing the URL into your browser and be able to see all of that code. So that completes the lecture, and I will see you guys soon.